So my talk is about the applicability of mathematics, and probably from the title you can tell it's about Eugene Wigner's paper. Eugene Wigner is a physicist that in 1960s he wrote this very popular paper called The Unreasonable Effectiveness of Mathematics in the Natural Sciences. I'm sure a lot of you have read it. There he wrote, the enormous usefulness of mathematics in natural sciences is something bordering on the mysterious, and there is no rational explanation for it. He also wrote, the miracle of the appropriateness of the language of mathematics for the formulation of the laws of physics is a wonderful gift which we neither understand nor deserve. Deserving aside, we don't like not understanding things. So I'm going to talk to you a little bit about the responses that there has been to Wigner's puzzle, mystery. So some people have written about the unreasonable ineffectiveness of mathematics in economics. Some people have written about the reasonable ineffectiveness of mathematics in biology. Some have written about the unreasonable ineffectiveness of mathematics, and so on. So the list of responses is very long. But you might say, if you have read the paper, that Wigner's project is about physics, is about modern physics. In relation to the applicability of mathematics, there are wide variety of responses. Perhaps some of you share these. So some say, you know why mathematics is applicable in physics is because we live in a mathematical universe. Or you might think that the universe is user-friendly, as Mark Steiner has argued, you know, we are the center of the universe has been created for us, therefore we understand it with our mathematics. Or you might think that the nature is written in the language of mathematics, and so on. So the wide variety of responses points out to different philosophies of mathematics and philosophies of physics. Depending on what school you pick, you're in more or less trouble with the applicability of mathematics. Martin Gardner also wrote about mathematics, and I just read a sentence from this quote that if a photon or a quark or a superstring is not made of mathematics, pray tell me what it is made of. So physics and pure math are very close to each other. So as you're realizing, this is another version of a philosophy of mathematics and physics. Source of the puzzle seems to be some kind of a distinctness. It seems on one hand, math has to do with abstract objects, it's pure, it's a priori. Physics is very different, it has to do with concrete objects, it's a posteriori, but they belong to very different domains. And so one might wonder if there is actually a problem there, or it's philosophically a pseudo-problem. So you might look at Wigner's definition, which says mathematics is the science of skillful operations and concepts that are invented for this purpose. You realize that it's a version of Hilbert's school formalism, so you say, well, you know, it's not really a puzzle there, it's a pseudo-problem because Wigner didn't really think right about what mathematics is and what physics is. Okay, so I'm proposing in my research project a new reading of Wigner. On one hand, I don't think that he says actually it's a mystery, so if you're interested, read my paper. I think what he's claiming is that only a subset of mathematical concepts are used. Some theories of physics that are written in the language of mathematics turn out to be actually false. Our knowledge of the universe is limited to the domains we find regularities and so on. So there is an elaborate description of how we can read Wigner's puzzle, which is the beginning of a new understanding about the applicability problem. The idea is that we shouldn't begin by definitions and ready-made philosophies. We might end there. So I think we start from the fact that mathematics is applicable and look at what we find about what mathematics really is and what physics is. Because I really want a G4G. I'm going to end here. I would love to collaborate with you on a project on the applicability of mathematics. Here are the list of some of the papers I've written, and thank you very much.